guys, Ms. Smith here again, and today we're going to review Chapter 7.7, how to add and subtract mixed numbers. Our essential question is, how can you add and subtract mixed numbers with like denominators? Let's look at our first example. After a party, there were 1 4/6 quesadillas left on one tray, and 2 3/6 quesadillas left on another tray. How much of the quesadillas were left in all? So we're going to have to add our mixed numbers. Let's think. Add the fractional parts of the mixed numbers first. So we're going to shade to model 4/6 and 3/6. So I've got 1/6, 2/6, 3/6, 4/6. Then 1/6, 2/6, 3/6. If I count that all up using my model, I get 1, 2, 3, 4, 5, 6, 7. So far we've got 7/6. Let's look at step 2. For step 2, we're going to add the whole number parts. So we're going to model 1 plus 2. 1 whole 6 model, and then 1, 2. So this gives us 1, 2, 3 as our whole number. Now we move on to step 3. Step 3. There it is. We need to rename the sum because we can't just leave it as 3 7/6. That would be an improper fraction. Let's think. 7/6 is greater than 1. So we're going to group wholes together to rename the sum. The model shows a total of how many wholes? We have 1, 2, 3, 4 wholes in our model. And we have 1/6 left over. So if we think of it this way, 3 7/6 equals 3 plus 6/6 plus 1/6. So 3 plus 1 plus 1/6 equals 4 and 1/6. So there were 4 wholes and 1/6 quesadillas left. Let's look at a subtraction problem. We need to find 3 4/6 minus 2 3/6. Our first step is to model. We're going to shade the model, show 3 4/6, which is of course our bigger number. So 1 whole, 2 whole, 3 wholes, and then 4/6. 1, 2, 3, 4. Now I'm going to take a different color and cross out the 2 3/6 to model the subtraction. I'll use purple. So I need to cross out 2 wholes, 1, 2, and 3/6. 1, 2, 3. Oop, I need my pen back. So the difference is, let's see, I have 1 whole left and 1/6. So if we were to record it as a vertical problem, we would get 1 and 1/6. So there would be 1 and 1/6 quesadillas left. Okay, here's another example. We're going to write the sum as a mixed number with the fractional part less than 1. So first, I need my pen. First, we're going to add the whole numbers. We've got 1 plus 3 We know that equals 4. Now I'm going to add my fractions. So 1/6 plus 3/6 equals 4/6. So 4 plus 4/6 equals 4 and 4/6. But if we, now this is correct, but we could also put it in simplest terms. That would be 4 and 2/3. Either answer would be technically correct. All right, here's another one we're going to try. So first I'm going to add my whole numbers. 7 plus 4 for 11. And then I'm going to add my fractions. Sorry. I was so into doing the math, I lost my train of thought. So 4/6 plus 3/6 equals 7/6. So right now I have 11 and 7/6. But I need to make this part to less than 1. So I could think of it like 11 plus 6/6 plus 1/6. Or 11 plus 1 plus 1/6. So our final answer would be 12 and 1/6. And here we have another one. So let's just keep practicing. Starting with adding our whole numbers. 8 plus 3. I'm gonna write it all out first. That way I don't lose my room. Okay, 8 plus 3 is 11. And 1/3 plus 2/3 is 3/3. Then our answer, if we add it together, would be 11 and 3/3. But we know this equals a whole, so it would actually be 11 plus 1. We know that equals 12. See? Pretty easy. One more example. 7 4/8 plus 3 and 5/8. Adding our whole numbers first. I don't know why I wrote that. 5 plus 3 is 8. Then we've got 4/8 plus 5/8. Always keeping our like denominator the same. 4 plus 5 is 9. So if we add the whole and the fractions together, that's 8 and 9/8. But remember, we want this fractional part to be less than 1 whole. So we can convert that into 8 plus 8/8 plus 1/8. I'm going a little off board here, but you can see. Or 8 plus 1, because remember, this whole equals the same as 1, plus 1/8. I'm going to go over here. So we got 9 plus 1/8, also known as 9 and 1/8. This is a little different. We're going to be doing our subtraction, but same idea. I'm going to start with my whole numbers. So 5 minus 2 is 3. And then doing my subtraction here. Subtracting my fractions. 7/8 minus 3/8 equals 4/8. If I put that back together now, it's 3 and 4/8. Or you could also write it as 3 and 1/2 if we're doing simplest terms. Yep. Wait, I've got another one. And here, actually, I'm not even going to write it down here because I think we're pretty good. 3 minus 1 would be 4. 5 minus 3 would be 2/10. If you wanted to put that in simplest terms, whoops, why did I say 4? Oh no, I added instead of subtracting. I am so sorry. That would be 2. Oh, it's a long day at home for Miss Smith. 2 and 1/5 or 2 and 2/10 would be the answer. All right, for this last one, why don't we do the model method again? So we stay in practice. I've got 7 holes. 1, 2, 3, 4, 5, 6, 7. And 3/4. So one more, we'll break into fourths. And 3/4. Let me just change my pen color here again so you can see it better. Red. So I'm going to minus 2. So I'm going to cross off 2 holes and 2/4. So if I count up what's left, I have 1, 2, 3, 4, 5 holes and 1/4. And that's already as simple as we can go. Whew. Another question, just switching back my pen here. Okay. The driving distance from Alex's house to the museum is 6 7/10 miles. What is the round trip distance? So, round trip is when we go to and then come back. So, if one trip there is 7/10, that's the first trip, the trip back is going to be the same amount. So, we're just going to add these two together. So, let's add our holes. 6 plus 6, I almost wrote the answer, is 12. And then 7/10 plus 7/10 equals 14/10. So if we add that back together over here, that would be 12 and 14/10. And to make this, fractional less than 1 like we have before, we could also think of this as 10/10 plus 4/10. Remember, 10/10 is a whole. You have all the parts there. So really, it would equal 1 whole, so 12 plus the 1 whole plus 4/10. This is 13 and 4/10. And if we want to do it in simplest terms, that would be 13 and 2/5. So the round trip from Alex's house to the museum is 13 and 2/5 miles. One more, we got a big one here. It's a hot problem. The Sampson family drove from home to a ski lodge, a distance of 55 and 45 4/5 miles. Sorry, 55 and 4/5 miles. And then drove an additional 12 and 4/5 miles to visit friends. If the family drove the same route back home, what was the total distance traveled? So, this is the distance from their home to the ski lodge, and this was their distance to visit their friends. So if we think of it like, then they drove backwards, we're going to add the same amount back. So we'll have 55 and 4/5 plus 55 and 4/5 plus our 12 and 4/5 and 12 and 4/5. I know, it seems like a lot. But let's, as usual, start by adding our whole numbers. So 5 and 5, 10. 5 and 5, 10. That's 110. And then 12 plus 12 be 24. Whew. And if we just want to, we could just add these now. This would equal 134 for our wholes. Now we have our fractions we need to add. So just looking for the right space. 4/5 plus 4/5 equals 8/5. Once again for the other one here. 4/5 plus 4/5 is 8/5. Add those together, that gives us 16/5. So 134 and 16/5. Now here's where it gets a little crazy, because we have to make this a fraction less than one whole. So 16/5 you could also think of as 5/5 plus 5/5 plus 5/5 plus 1/5. I ran out of room there, sorry. We add all these together to get 3 wholes, because each one is one whole. So then we'd have 134 plus 3 plus 1/5. 137 1/5. And we're already at simplest terms, so we don't have to do anything else. 137 miles. 137 and 1/5 miles. Sorry, someone just spoke to me off camera. Okay, last problem. Jeff used 4 7/8 of orange juice and 3 1/8 cups of pineapple juice to make tropical punch. How much more orange juice than pineapple juice did Jeff use? So let's start off. Is this an addition or a subtraction problem? Let's see. We want to know how much more he used. So it's going to be subtraction. We've got our two numbers, 4 and 7/8 minus 3 and 1/8. I think I'll draw a model for this one. I like doing models. So we'll do our number we're subtracting from. Got 4 wholes. I'm going to draw 8. It can be tricky sometimes. I'm going to color in 7. 1, 2, 3, 4, 5, 6, 7, 8. Let me get my other color here. We'll do green. Gonna minus 3, so minus 3 wholes and minus 1/8. What we have left is 1 whole and 1, 2, 3, 4, 5. Oh, 6/8. I was like, wait, this answer isn't here, but that's because we need to put it in simplest terms. Then we'll get 1 3/4. Let's see if we were right. Yes, we were right. Good job, everybody. Okay, let's take a look at our essential question now that we're done. How can you add and subtract mixed numbers with like denominators? Well, when adding, I can model both mixed numbers. I add the fractions first, and then the whole numbers. Then I rename if I have to. When subtracting, I can model the first mixed number and cross out the value of the second mixed number. Well, thanks for enjoying this review with me, guys. I hope you have a great day. Bye!